Hey, this is the key to quiz 12. Okay, so we're getting a regression line. So I'm just going to do it in the calculator rather than by hand. So you go to Stat, Edit, and go up here and Clear. And then Clear. Alright, 0, 1, 6, 7, 17, 18, 19. 3.8, 4.25, 4.8, 5.05, 5.75, 6.25, 7.15. So just making sure these are right. Okay, so then you go Stat, Calc, then your regression. Probably going to use this, so I'm going to store it in Y1. Okay, so that's the line. You can see that it's in here. Okay, and if you want, you can just turn your stat plot on, and then your window 0 to 20 on X. Scale by 5 is just fine. And then maybe 2 to 8 on Y. I'll go 0 to 8, why not? Scale by 1. So now you see all the points plotted and the line through them. Okay. Looking good, everything's making sense. So I'm just going to round this off to a couple of decimal places. So 0.14 x plus 3.96 it looks like. Okay, good enough. You can see that that's pretty good estimate, because if you just go 0.14 x plus 3.97 and then graph it, it's going to be pretty, it's basically right. So, good enough. Not much work to show there. Use it to predict the minimum hourly wage in 2029. Well, so this is years since 1990, so 2029 would be 39, right? 10 years in would be the year 2000, so you have to add 10 to 29, so it's 39. So you can just go to your table. I bet both of these lines will agree with each other at 39. Nope, they don't. Okay, so yeah, our estimate is pretty far off after a while. I'll accept either one of these answers. I'm going to go with the more accurate one though. $9.30 is what that rounds to. Okay. Depending on how much accuracy you choose to go with there, it's going to give you a better number. Okay, anyway, moving along. That's right, that's it, right? Okay. Each unit of the product can be made on either machine A or B. The nature of the machine makes their cost functions differ. Total cost is this. How many units should be made on each machine in order to maximize total cost if X plus Y is that? Well, okay, minimize this sum here. So Adding these, you're going to get 190 plus 1/6 x squared plus 1/9 y cubed. Okay. We can actually, the funny thing about this is that they want you to do this by Lagrange multipliers, but I don't really feel like doing that, so you can actually just sub one of these things out. So I'm going to sub out the x squared. So x is 10 100 minus y, so you can just make it a single variable function by going like this. It's not the way you're supposed to do it, but it's way easier. Now you just do calc 1 minimization. Gone. Square comes down, becomes 1/3. And then you would multiply by -1 because of the derivative of the inside. This becomes 1/3 y squared. Set the derivative to 0. Distribute the -1. So this becomes 1/3 y minus this thing over 3, right? Plus 1/3 y squared equals 0. And multiply by 3. So y squared plus y minus this is 0. So that's a really irritating equation to try to solve. Just going to use the quadratic formula. Y equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. So what is that? This becomes a positive. So 40,400 plus 1. So 100, and then the other one would be negative, so we can ignore that, right? We can't use the negative one because y is a number of units, right? So you can't have a negative number of units, so it's 100. So if y is 100, then the other one's got to be 10,000. Okay, so answering this question, how many units should be made on each machine? Machine B is the y's, so machine B makes 100 units. Machine A makes 10,000 units.